Alright, welcome to today's mini lecture. In today's mini lecture, we are going to be looking at the ideal gas law. So the formula for the ideal gas law is PV equals nRT. In yesterday's mini lecture, we talked about the combined gas law, and we discussed that there are 4 different variables that come into play. The combined gas law only addresses 3 of those variables, and you can see that it is the pressure, the volume, and the temperature. Well, the ideal gas law is going to go through and address the 4th variable, which is the little n, which is the number of moles. So we have PV equals nRT. Now, when in chemistry, we often refer to this as PIV-NERT. Instead of saying PV equals nRT, we just say PIV-NERT, the gas law's equations. So if you hear that, it's just simply something that was kind of a nickname that's given to that, PV, PIV, and then nRT, NERT. So if you hear that, you'll know what we're talking about. All right, there's another variable that comes in, or another letter, which is a capital R, and this capital R is not a variable at all. It's actually the gas law constant. And if you look, there's 2 gas law constants that you can have. We have 0.0821, and that one's going to be measured in liters atmosphere per moles Kelvin, and then you have 8.314 liters kilopascals per mole Kelvin. So it takes into consideration all 4 of the variables, the volume, the pressure, the number of moles, and the temperature. The difference is what the pressure is going to be measured in. Like in this one, it's atmospheres, and this one is kilopascals. So whenever you're using this, how do you know which R value to use? Well, you have to look at your P. The P value, or pressure, is going to be what determines which one of these I use. So what I would like to do is I would like to just skip down just a little bit and do a couple of example questions for you. So I'm going to read the first question. It says, how many moles, so I'm going to circle moles, of gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 Kelvin. So it's already in Kelvin, so I'm good to go there. I don't need to do any conversions, but I did write down the formula right here for Kelvin. Kelvin is equal to 273 plus degrees Celsius. So I'm going to go through and rearrange the formula, PV equals nRT, to solve for my number of moles. And I'm just going to start substituting in. So the P is going to be 2.3 atmospheres, and I'm going to multiply that by 120 liters, which is the volume. Now I'm going to divide it by R and T. So my R value is going to be dependent upon what I use here, which is an atmosphere. So I'm going to use the first one, 0.0821. I'm going to leave that like that, and then T. My temperature is 340 Kelvin. So guys, if you need to pause it right here in order to punch this in on your calculator, go ahead and hit the pause button, punch it in, get your answer, and then continue. All right, that was pretty good. When I did this, I got my answer to be 9.89 moles. So see if you get the same thing, 9.89 moles. All right, let me go ahead and look at question number 2. It says, if you have a 50-liter container that holds 45 moles of a gas at a temperature of 200 degrees Celsius. So guys, if you look at the moles, I'm given the volume, I'm looking for, usually whenever you're dealing with gas come up, you're usually having to PIV-NERT equation. Now PV equals RT, pressure, so that means that on itself, so I have N in the numerator, volume. So I'm just going to go back in. It says that I have 5, and then my R, my pressure, but guys, the equation comes up, you have to either just choose one of these and do it, Or choice question is look at what your answers for your pressure. You come back up and you use them. I am going to use one which is 081 T 200. So I have to make sure I 3. I can do that math. 173. All of this, which is 50. Leave all of this in. Go ahead and then you can start it back. Answer. And my answer 4 point atmospheres. We're in atmospheres because 082. What I would like to work another problem for you. What I would like to do is go down and do number 5. Problems and mold problems, just come down and work. Oh, y'all see my cheat sheet down here? Okay, y'all thought I was doing. So let's go through and we can hold 100 liters volume. It says if 3 of 1 at the temperature. Make sure that you understand what the gases are so tiny way. So the moles, then you gas law. So the V equals. So now I'm going to get temperature is going over. I'm just going to go through and T is equal. Let's put 180. Then it's going and it says that I do have atmospheres 0.0 and moles 3. I'm going to get my answer in 6.2 Kelvin. Guys, we use degrees Kelvin, but if they ever ask you back to up here and say 2 is equal to degrees Celsius, 106.2. So my degree is going to be 0.2 degrees Celsius. Problems for you. Before I leave, I would like one more formula. I always say exam. I mean, like the day before. When you're walking in, don't give you on your form. He asked you a question. It makes life so much easier. So it just takes you stepwise. So gas. So MM mass divided by T. The volume, number of moles out. So like on your AP exam,